Today we are going to discuss about elementary row operations or column operations in matrices. So this is the last portion of the matrices. So there are normally 6 rules for row operations or column operations. So first thing, when you are using row operations, then you have to use only the row operation. Okay. Suppose you are using row operation, that means you cannot use any column operation over there. And when you are using the column operations, then you cannot be used any row operation over there. So that means for finding A inverse, we are using elementary row operations. But there are 6 elementary row operations are there, 3 elementary row operations and 3 elementary column operations. Okay. So 3 elementary row operations and 3 elementary column operations are there. In number 1, interchange of any 2 rows or column. Interchange of any 2 rows or columns. So now, if we write A equals to 1, 2, 3, 5, 8, 9, 10, 13, 15. So if we use R1 interchanging with R2, that means A equals to 5, 8, 9, 1, 2, 3, 10, 13, 15. Okay. Otherwise, if A equals to 1, 2, 3, 5, 8, 9, 10, 13, 15 is there, and you are using C1 interchanging with C2, that means A equals to 2, 8, 13, 1, 5, 10, 3, 9, 15. Okay. So these are the changing for this. Now see that we know that for determinant, if we change, in determinant, if we change, the sign will be changed. Okay, the minus sign will multiply over there. But for row operations, no minus will multiply over here. Okay. So now, next rule. Next rule, see that if we multiply of the elements of any row or column by a non-zero number, that means if A equals to 1, 2, 3, 2, 3, 4, 3, 4, 5, then R1 we can write 2 of R2. So that means A equals to so R2 interchanging with 2 R2, that means 1, 2, 3, 4, 6, 8 and 3, 4, 5. Similarly, for column also, if we write 1, 2, 3, 2, 3, 4, 3, 4, 5 and C1 interchanging with C2, C1, that means equals to 1 into 2, that means 2, 4, 6, 2, 3, 4, and 3, 4, 5. Okay. Now, the last rule is very important. Okay. Now, see that. So, in the last rule, the addition to elements of any row or any column, the responding elements of any other row or column multiplied by any non-zero number. So, in number 3, see that if A equals to 1, 2, 3, 4, 5, 8, 9, 12, 15 is there, we are applying R1 plus 2 or 2. Okay. So that means A equals to 9, 12, 19, 4, 5, 8, 9, 12, 15. Similarly, for column operation, A equals to the same matrix 1, 2, 3, 4, 5, 8, 9, 12, 15. We are applying C1, that is C1 plus 2 C2. Okay. Now that is A equals to 5, 2, 3, 14, 5, 8, 33, 12, 15. So this is the rule for finding elementary row operation or column operation. Now we are discussing about invertible matrix. See that. So invertible matrix. So what is the invertible matrix? So whose inverse exists, then means this is invertible matrix. Okay. So if A and B are square matrix of order M, then we can say that AB equals to BA, that is identity matrix. So B is called inverse of A. So B is called inverse of A, or A is called inverse of B. So that means A equals to B inverse or B equals to A inverse. Also, we can say that A inverse equals to I. If we will discuss about that, this property, A inverse equals to I. Now, this is the main property for finding the inverse of a matrix by elementary operation. Now, I am showing you how to calculate the elementary operation. See that. So now see that for finding inverse of a matrix by elementary operation, two types of problems there, that is with elementary row operation and one is elementary column operation. This is ECO. Okay. This is elementary column operation and this is elementary row operation. So that means here we are only changing this process. That means we are expressing x equals to AB. We are calculating this position and this position. That means A equals to IA. Okay. So if we change this position, that means after calculation we get I equals to B and B is here A inverse. Okay. Similarly, for the elementary column operation, we are taking A equals to AI. This is the difference. We are taking here A equals to IA, and over there for column operations we are taking A equals to AI. So that means after calculation we get this is AB. So AB means B is a inverse here. So this is the difference between the column operation and the row operations. Now I am showing an example for the elementary operation of 2 by 2 matrix. See that. So number is given 1 minus 1 2 3. Okay. So this is given. You have to find the row operation or column operation, and we have to make and find the A inverse. So I'm writing here using row operations we get. So for row operations A equals to IA. So now where is the A? A is given. So write over here 1 minus 1 2 3, and this is I. So 1 0 0 1, and this is same A. Now we have to change this matrix by operations 1 0 0 1 and this matrix in the form of inverse. Then we get I equals to BA, and B is the inverse of the matrix. So now I am applying row 2 minus 2R1. Okay. So I am applying row 2 minus 2R1. Then we get 1, this is 1 minus 1 0 5. Similarly for this one also, first row is same, minus 2 1, and A is as same as given. Next one, 5 is there, so that means row 2 implies 1 by 5 R2. Okay, so that means 1 0 minus 1 1, here 1 0 minus 2 by 5 1 by 5. Next one, if we add these two row we get 0, right? So we are applying row 1 plus row 2. So that means 1 0 0 1 equals to 3 by 5, 1 by 5, A is there, minus 2 by 5, 1 by 5. Check it once again. 1 0 0 1, okay, minus 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. Okay, so A is there. So that means we are transferred this form A equals to IA in the form I equals to BA, right? As we had discussed previously. So this is the B, and B means A inverse. So the A inverse is, 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. Okay, so this is the A inverse of this question. Okay. Now we are discussing another problem of 3 by 3 matrix. See that. So see that A equals to 2 minus 3, 3, 2, 2, 3, 3 minus 2, 2. This is the A. Now using elementary operations, we get A equals to I A. So that means 2 minus 3, 3, 2, 2, 3, 3 minus 2, 2 equals to I means 1, 0, 0, 0, 1, 0, 0, 0, 1 and AH shape. Now, first I am interchanging row 1 and row 3. So I am firstly interchanging row 1 and row 3. That means 3, 3, 2, 3, 2 minus 2, 2, 2, 3. And here 0, 0, 1, 0, 1, 0, 1, 0, 0. Now applying R1 minus R2. Okay. R1 minus R2. Then we can write 1 minus 4 minus 1, 2, 2, 3, 2 minus 3, 3. This equals to 0, 0, 1, minus 1, 1, 0, 1, 0, 0. Okay. Now, applying R3 minus 2R1. So that means 0, sorry, 0 not, this is 1. 1 minus 4, 1. 0, 5, 0. 2 minus 3, 3. Similarly, 0 minus 1, 1. Minus 1, 1, 0. 1, 0, 0. Okay. Now, similarly applying R3 minus R2, R3 minus R2, that means 1 minus 4, 1, 0, 5, 0, 0, 5, 5. Okay. And this one 0 minus 1, 1, minus 1, 1, 0, and 1, 2 minus 2. Okay. Now that implies R2 1 by 5 R2 and R3 similarly 1 by 5 R3. So if we apply these two, we get 1 minus 4 1 0 1 0 0 1 1, and here 0 minus 1 1 minus 1 by 5 1 by 5 0 1 by 5 2 by 5 minus 2 by 5. Now row 1 equals to row 1 plus 4 row 2. Okay, so row 1 plus 4 row 2. Apply it. So now we get 1 0 minus 1 0 1 0 0 0 1. Okay, sorry, this is 0, not maths, that's all. So in the right hand side, minus 4 by 5 minus 1 by 5 1 and minus 1 by 5 1 by 5 0 2 by 5 1 by 5 minus 2 by 5. Okay, now next line. So 1 0 0 0 1 0 0 0 1. A equals to, we are applying row 1 plus row 3. And the right hand side is minus 2 by 5 0 3 by 5 minus 1 by 5 1 by 5 0 2 by 5 1 by 5 minus 2 by 5. Okay, so we get I here, this is I3 and this is B, and this is the A inverse of the given matrix. Okay, so this is the answer. This is the A inverse of the given matrix. Okay, so thank you all of you. Practice in home. Lots of sums are there in exercise. Do it. These are all the sums of the chapters which we are completing in this session at the holiday homework for you. Please do it, all of you. Practice it at home. Don't waste your time. Stay safe. Take care. Bye bye.